Hey everyone, welcome to the new video on this channel. Today we're talking about PySpark. So what is PySpark? PySpark is a Python API for Apache Spark, and Apache Spark is an engine to be working on huge data sets using distributed computing systems, aka cluster. So through PySpark, we define our data processing pipelines, and then Apache Spark takes care of all the optimization, orchestration, and things that we don't want to think about. As I said, these pipelines usually run on clusters, but they can also run locally, which is exactly what we're going to be doing today. I know that Apache Spark is quite an old technology, so some of you might be wondering why the hell would I want to cover this? Well, for me, the reason is quite simple. I started working with this personally, so I wanted to share my knowledge with you. And then also, while I was learning PySpark, I noticed that not a lot of resources go into real-world scenarios showing you practical code. Most of it is theoretical or using very simple toy examples. So I decided to do a step-by-step project showing you how I would use PySpark. And keep in mind, I'm not a professional still at this, so there might be some mistakes or some inefficiencies, and please let me know about them in the comments. First of all, I would like to discuss why we want to use PySpark. First, it can handle huge data sets. Because it can work on distributed systems, it allows us to parallelize a lot of our processing, which means that we can split the data set into multiple batches and work on them individually. And then Apache Spark takes care of bringing it all together into a nice output. Second of all, it's quite fast, especially if you have quite a nice chunky cluster, because again, it works by parallelizing, which speeds up a lot of the operations. And finally, it can handle streaming data as well, which is quite nice. I haven't really worked with it yet, but I hope to cover it in some of my future videos. Now, when would we want to use PySpark over, let's say, pandas or polars, which I was covering on my channel before? The answer is quite simple. If our dataset does not fit in memory, that's when we go to PySpark. Because of the way it works, it can handle datasets that are larger than memory, and we can submit our jobs to clusters, which are then going to be able to handle even larger data sets. Now, the second of all is, of course, the cluster. If you have a computing cluster, access to it through work or maybe your education, then I highly recommend using PySpark. It's going to speed up a lot of operations for you. And finally, if you already have production-ready pipelines somewhere using Apache Spark, then deploying a new one is going to be a no-brainer for you. So that's when you would want to use PySpark. But then also equally important to understand when not to use it. If your dataset fits into memory, I highly recommend using polars or pandas if you haven't learned polars yet. And I have a few videos on my channel to help you learn it. So if you're interested, click right there. And also if you want to do a quick EDA, then it might be better just to take a sample of the data and to do a quick analysis rather than designing elaborate data processing pipelines in PySpark, because development is hard. Debugging is going to be an issue. It has a lot of unique quirks, so I hope through these videos you'll see some of them and you'll learn to work with them, but then also understand you don't really need it if you just want to do a quick EDA. Now, first challenge you will encounter is installing it. And I have Mac, so all of these steps are going to be specific for Mac, but I assume they're going to be quite similar in other devices as well. Now, pip installing PySpark is nothing complicated, right? So you can either pip install it, or you can use Conda and then Conda install it. It's not going to be that hard, and I hope it runs for you without any issues. One thing I would recommend is create a new environment for PySpark, because it has a lot of dependencies and you don't want to mess up something that you've already set up. But it's not going to run just like that. You also need to install Java if you don't have it yet. And more specifically, I recommend using Java 11 or OpenJDK, which is an open source version. 11 is the version that is supported so far by PySpark, and I found the least amount of bugs with it. But you can also install the latest one and see what you get from it. It can be installed using Brew, or actually it can also be installed using Conda, but there might be some additional steps involved of setting up some environment variables and symlinks. So just keep an eye out on the prompts in the terminal that is going to give you. Once you have everything installed, you can check if it's working by calling java --version. And for me, as you can see, I installed the OpenJDK 11. And then also after the brew install has finished, it gave you a few suggestions on how to specify the correct paths. So I highly recommend following these steps. And then you will know that PySpark is working by just calling PySpark. That's not it. PySpark. And you can see that it's going to launch this application here. And you can see the version of my Python, and then also the version of PySpark. It's 3.5. And basically, yeah, you can work with it directly in the terminal, but we're going to be working in the notebooks. So this is just to double check that everything is installed properly. Now let's exit. So let's begin with the setup of the notebook. First things first, let's download the data. As always, I'm taking dataset from Kaggle so that we can go through this project together. And this particular time, I'm going to be working with a dataset called malware detection in network traffic data. It's quite an easy artificial dataset for detecting anomalous activity in the network traffic. It's quite big, so that's the advantage. We'll be able to see the capabilities of PySpark, and it's quite easy to work with, so that's why I chose it. Also, it lends itself nicely for some of the aggregations that we'll be doing later on, and so yeah, that's why I thought it would be a nice dataset. Now you can download it from Kaggle. I already have it, and I put it into a folder called PySpark, and you can also check out the Spark intro notebook, and you can check it out in the GitHub. If you go to my repository, tutorials, and inside of the let's go PySpark, you'll be able to see a Spark intro notebook. So make sure to pull it, and let's go through it together. First thing that you'll notice that when working with PySpark, especially in transitioning from pandas, is that all of the functions need to be imported. And I found this quite weird because, as you know, pandas and Python in general is very class-oriented. So having a lot of these functions felt just weird, but that's how it works. You can import them directly from PySpark SQL functions, and then import functions like maximum, sum, average, column, etc. I saw some people do as well this notation, so they do import PySpark SQL functions as f, and then they apply these functions going f.max. So whichever you prefer, I decided to explicitly state them here, but I also know that sometimes in the notebook I'm going to be using another notation. So just that's something to watch out for. And there is interesting thing with PySpark is that there is two ways, more than two ways, but the two ways for Python to work with it. First of all, it's using a SQL API, and the SQL API, you don't need to write SQL there. You can if you want. It's a fully functional query engine as well, but you can actually write Python code while working in this SQL API paradigm, or you can actually try to port as much of your Pandas code into PySpark by using the Pandas on Spark extension that they recently introduced. It turns out that this is actually a port of a library called Koalas that was a substitute for Pandas but for PySpark, and now it fully lives inside of the PySpark environment. So you can do it like this as well, and the syntax is exactly the same, but the functionality can be a bit limiting for now at least. I know that they're constantly developing it, so maybe at some point you won't even need to learn this tricky syntax. But for now, it is how it is, and I'm going to be working with the SQL functionality just because it's a bit more flexible. And now let's begin with reading the data. So what I defined here, I defined the file paths, and you can actually see that it's referring to a list of two files, and these files are just the first CSVs here. And Spark in this way is quite nice that it can actually read the list of CSVs. So I'm not sure if you can do this in Pandas, but I found it quite neat. And what you need to do first is you need to initiate the Spark session, and you do this by calling Spark session builder, giving it an app name, and then calling get or create. So if you already have this session, it's going to get it, and if it's a new session, this session is going to be created. And then I'm also setting the log level so that I'm getting as much logs as I want. For now I set it to the error level, so I'm not going to be getting so many logs. And then I'm also printing out the version of the Spark. And let's go. So choosing the environment, I'm working with the virtual environment, and I suggest you do as well. And let's actually import everything and let's run it. And what it's telling me is that it's using this address to launch an interface for monitoring your PySpark logs. And now let's read in the data set. It's going to be not as straightforward as it is with pandas. With pandas we do pd.read.csv. Here you need to go to Spark, and Spark, remember, is your session, so it's not the Python package that you imported, which is called PySpark, but it's a Spark session, and you tell it to read a CSV with some of the options, and we're also telling it to infer the schema and that our data set has a header. There's a few other parameters you can specify, but for now that should be enough. And as you can see, it's going to be reading it in. And it's actually read in 2 files, right? Because remember I specified the list here. So it's going to work equally well with single file or with multiple files. And we can see, that the data is read in, all looks good. So we can see that the missing values are represented by the minus. So that's something that we will correct a bit later. There are some dates, and there are some strings, and there are some floats. So how do we know what data types were actually inferred? Well, it's quite easy. First of all, you can just call df, and it's going to tell you, it's going to show you like this, but that's not really that convenient. So what we can do, we can call print schema, right? Yeah, print schema, and then it's going to print it out in a nice way. You can see that, for example, that the timestamp was interpreted as a double. Then there is some strings, there is some doubles again, so double is a float. And so this way you can see all of the type, and you can see if the column is nullable as well, so can it have null values. And now that the dataset is read in, let's begin with processing. First things first, we saw this timestamp, which is represented as a number, so as a float to be specific. And we want to translate it from Unix time. It's a Unix time, it's number of seconds that took place from a specific point in time. I already don't remember which one it was. There it is, from 1970. So we can just call from Unix time. And remember, Unix time is one of the functions that we've imported from here. Then we're going to call it on a column called TS. Notice that we're not directly working with the column, but we need to work with the whole data frame and then reassign it back to the data frame object. And there is a very specific reason for it. The data frames in PySpark and Spark in general are immutable, so we cannot change it in place. Instead, we need to change something in there, and then we need to assign it to a new variable. You can reassign it to the same variable, and this way you're kind of like achieving this in place substitution, but you need to do this explicitly. And so for this reason, you cannot also do operations on a column, which I found quite weird and quite unintuitive to work with. So we wouldn't be able to do like this, right? So we wouldn't be able to do tfts and then, call something, or even do like from Unix time, right? And then, reassign it back to a dfts. So that's, a big no-no. The data frame does not support item assignment. So this is something to get used to. Instead, what we do call the method called with_column, and with_column essentially creates a new column. So first of all, you specify what's the name of this column. It's going to be dt, and what's going to be contained in this column is going to be from Unix time, from the column called ts. That's the first transformation we do, and then we actually chain this transformation, so we change our data frame 2 times. So this line is going to modify the data frame 2 times and assign it back to the original name, so that it appears that we did it in place. And then when we print out the schema now, we'll be able to see a new column called dt, and it's going to have a method. It's going to have a data type called timestamp. And how can we show it? Well, usually you would go ahead and like do a head, right? And it works here, but it returns you a row object. A row object, it is basically a tuple or a list, and it's a named list. You can iterate over it. For example, selecting the null, the first element, we're going to get the timestamp value. We are, but it doesn't showcase as a data frame, like the way that we're used to with pandas. And to get that behavior, we actually need to call df.show. So what df.show does, it evaluates the data frame and shows us the first 20 rows. We can adjust it to show just 5, to behave just like a head. And this is going to be our new data frame. One interesting thing with all of these PySpark data frames is that they're lazy evaluation. So when I define this, as you can see, it took 0 seconds because nothing really happened there. It didn't do any real calculations. I just defined the course of action that I want to read in the data, that I want to transform the timestamp into a datetime, and I want to transform the datetime string into a timestamp. So, and only when I call show or collect, it's going to actually run it. So here it also took 0 seconds approximately because it's a very small operation, but we'll see later how it works. The definition versus the execution. Second thing that we want to do in the pre-processing, we want to rename some of the columns. As you saw, it's called ID response age or ID orig p. So very unintuitive names, and going through the data dictionary, I actually saw what they mean. And I can see that orig age, for example, is the source IP, and then this maps to the source port and destination IP and the destination port. And renaming columns, again, is not as straightforward as it is in pandas, because we cannot change anything about the data frame without redefining it. So that's why you need to call with columns renamed and then map one column to another. There is a similar method in pandas, but I used to always do it like this. So I used to go, columns and then just redefining them, but it's not going to work here, unfortunately. So yeah, that's 2 small pre-processing steps that we did, and we saw how to work with the data frames, that we cannot just take them and modify them as we are used with pandas, but instead we need to be a bit more careful and use methods called with column, or also we can use a method called select that also is going to return you a column, the one column that you specify. It's kind of like selection method here. Instead of just getting whole data frame and then appending a column, select method is going to just take one column and do something with it. Now let's do some basic quality checks. For example, we saw that we processed this datetime string, and now let's see what's the minimum and what's the maximum of it. And we can see that here I'm calling, it's formatted a bit. So I'm calling the minimum and then I'm calling the maximum methods, functions, that I do here inside of the aggregation context. And again, this is one important thing. You cannot do df dt, right? Then you cannot do max like this, how you would do it usually. You cannot do it like this because it's not the same column as you have in pandas. So instead what we need to do, we need to call the aggregation context. This way PySpark is going to know that we want to aggregate a column. And here we're going to call the minimum function on the dt column. And this handy method .alias is changing the name of the output column. So without it, for example, it would just tell us what type of operation was performed on which column. And you can see that here it would be minimum dt, but instead, let's give it something more useful and call it a minimum date. And we can see that we have a data set ranging from April 9th to April 21st. That's good to know. Now let's check the shapes of the data frame. Again, data frame doesn't have a shape because it differs from pandas. So instead what we need to do, we need to call count. Count is going to count the number of rows, and then length of the columns is going to give you the number of columns. So that's how we can approach this. And then a few standard checks that you would do are the nulls and checking for the missing data. So first of all, let's check for the static columns because it was a bit more tricky than I thought it would be. So it's good to cover. I selected a bunch of columns that I wanted to analyze because, for example, doing static analysis on, let's say, datetime or the timestamps wouldn't really make a lot of sense, or unique IDs as well wouldn't make a lot of sense. So I selected the bunch of columns that I wanted to analyze. And then again, inside of the aggregate function, what I'm doing, I'm calling this function called countDistinct on each column inside of the toAnalyze list. So this has created a tuple of the operations that I want to perform, and calling this star method, basically telling it to aggregate all of these elements inside of this tuple. This is going to be assigned to a new data frame called unique counts, and showing it, that's how it shows like this. You can see that, for example, proto column has 3 unique values, and some of them have 1 unique value, for example, like local response or missed bytes. So it's good to know. And I want to select these columns that have only 1 unique value and to drop them. How do I do this? Let's actually split this into 2 so that you can see. One thing about PySpark that I'm really not happy about is the logs that it gives you. There's a lot of noise in it, and it sometimes can be quite hard to understand. Luckily for me, here it wasn't that hard. So here you can see that parameter with name source IP cannot be resolved. Basically, column was not there. That's because I didn't run the previous step of renaming things. Yeah, easy mistake to make. Now let's run this again, and now it should be working all fine. So you can see this execution progress bar here. It's quite useful to see if your operations are stuck or it's going according to the plan. And so I have this unique counts, and the second part here was selecting first. So select first like this. What it does is it essentially picks the first row like this. Could be also head 1. Same thing. And I assign it to the unique counts variable. So unique counts becomes a name tuple. And what's going to happen here is that I'm just kind of selecting which of these counts is equal to 1 and printing it out and then dropping. And again, drop usually works on 1 column, but we can specify multiple columns if we call this star method on a tuple. So let's run it. It does the same operation. It usually caches it, so that's why it's going to take less time than in the first step, but it still needs to kind of retrieve the cache, so it might be a bit slower than you would expect it to be. Let's check the unique counts. Yeah, you can see that it's a row, and then static column is actually a list. Okay, let's move on to the next step. In this part, I'm calculating the number of distinct values in a few columns. Nothing interesting here, except that I'm using a select method that I told you about, which selects just a single column and does operations on it. And then I'm calling a distinct method to count the number of distinct values. Yeah, nothing too complicated here. And then for the count nulls, the way to do this is a bit more complicated than in Pandas, but it's still a few lines of code, so it's not that bad. First things first, we need to replace this minus signs that we saw with the null value, or I replace it here with none. PySpark can have multiple values for null, so really be careful what you're checking for here. In this case, what I'm doing, I'm checking for is none, and I'm calling it, or I'm also checking if the column is null. So 2 conditions, it's going to be 2 separate null values. Just something to keep in mind. Again, very different from working with in Pandas. Here I'm doing function again, and then I'm doing when. So you can see, like I didn't import this when and is none in the beginning, and instead I'm just accessing them using functions namespace. So that's also possible, as I said, whatever you prefer. And what I'm doing, I'm basically counting where the column is none or is null. And I'm doing list comprehension here, so it's doing for all the remaining columns. Remaining columns are those that I specified that I want to analyze, and they're not in the static columns. And then I'm using a select method to create a new data frame with new columns, and then I'm calling a show to showcase the results. And you can see here, let's run this. And as you can see, it takes some time, and we can see that most of the columns have no null values, and some of them have quite a lot of null values, for example, like service. So something that we might consider dropping. So we've performed some basic operations for data processing and for data quality checks. There's a lot more we could do, of course, but let's move on to some exploratory data analysis. First things that I do when I get a time data, do time series plots. That's exactly what I'm doing here. There is this function in PySpark called dateTrunc, and it basically truncates the whole datetime objects that we had, dt, into the grain that you specify. So day, hour, minute, and second. And that's what I'm doing here. And you can see if I do the fshow now, it's going to show me 4 new columns: day, hour, minute, and second. And then you can also see all the changes that we did, like with null values, for example. Now let's delete this. And here I did a small for loop to do count of events that happen on the specific day or hour or minute. I'm doing this using, again, the aggregates, but now I'm doing it within the group by context. So you can see the main logic here. What I'm doing basically is that I'm grouping by a certain column. So for example, hour. And then I'm also grouping by a label. So it's a multi-index group by. And inside of the aggregation method, which is similar to how you could also do this in pandas, I'm specifying what aggregation do I want to do. In this case, I want to do count, and on which column do I want to perform it. That's UID, so I want to count amount of UIDs, and I also want to alias it with a new name called counts. Finally, I want to order it by hour, right? Because I wanted my time series to be ordered. And then what I'm doing, I am transitioning it to pandas. And if you can see it here, it returns me a pandas data frame. So that's a very nice thing here. You can easily translate PySpark data frame to pandas and from pandas to PySpark. So if there is like any elements that you cannot really do in PySpark, or you're too lazy maybe to specify specific syntax, then it's a very useful method. Yeah, let's remove it here for now. And I'm doing this because a lot of the plotting libraries, most of the plotting libraries don't have native support for PySpark. So that's why you need to go to pandas and then kind of do all the other things in PySpark. It's a bit annoying, but it is what it is. Yeah, and then just doing plotly line. So let's plot it, and we can see that events per day. We can actually see interesting thing here that like malicious activity is much more prevalent than benign activity, which is quite interesting. But yeah, we can see aggregates on the minutes, on the hour, and on the daily level. Now the next part is a univariate data analysis showing the distributions of specific columns, be it a numeric or a categorical. In this case, I'm just going to showcase the count plots. These are going to be bar plots with specific counts for a column. And what I'm doing here, as you can see from the outputs, I'm going to be showing you the value, how many times it occurs, and what's the percentage from the total takes. And I'm doing this again by doing the group by this certain variable that I specify in the function, doing the count, and then ordering by descending counts. This is ultimately how value counts works, but there is no value counts in PySpark, and so you need to recreate it like this. And then in the next one, I'm using with column. You already know that this just returns a original data frame with a new column, and this column is going to be called %. And what I'm doing here, I'm selecting the column count, and then I'm dividing it by the sum of the counts, so calculating the percentage. One thing to note here is that you need to add an over clause here, where you kind of add the window partitioning. In this case, I'm partitioning across all the data frame, so that's why I don't specify anything. So that's why it just sums the entire column. Basically like a trick to get the percentage. And then finally transitioning it to pandas to do plotting. And let's run it in the for loop for these 4 categorical values. So let's run it. And we can see that there is 3 values in Proto. ICMP being the least popular one. Then there is a service column where most of the values are null. That's what we saw in our null analysis as well. Then there is a connection state where we see majority of the values being S0 and then some values being SF or OTH, and then all the other values are less than 1%, so we might be considering to drop them. And for the label, we can see that we have more malicious examples than benign examples, which is quite interesting. Now let's call it a day. For univariate data analysis, we could plot a numerical data as well, but I believe that you can do this yourself, so treat it as an exercise if you are up to it. For now, what I'm interested in, I have this data frame which is relatively clean after we did all this pre-processing, and I'm interested in preparing it for modeling. In this cell, I'm doing two things. First of all, I'm ensuring that the data types are as they should be. So I selected these numerical columns and I'm making sure that they are represented as floats. And then I'm also filling in missing values, as you can see here. So I'm filling in numerical values with -99999, because that's usually how tree-based models treat null values. They need to be something outrageous so that they're very simple to kind of put aside. And then for the categorical values, I'm just filling it in with missing. And we can do it all in a for loop. As you can see here, again, I'm using with column to recast the columns, and then I'm doing fill in A to fill in the missing values. Both of these are dictionaries, and you can see that all of these methods work quite well with dictionaries as well, which is quite versatile, which is nice. Yeah, so if we just showcase the prepared data set, we can see that there is no more null values. We can see that some of the columns were dropped, and we can go ahead and create our full pipeline. Full pipeline is just going to be a summary of all of the pre-processing steps that we did, put together into a one pipeline that you can then deploy locally or on any other service. You can see here that I'm specifying what are the static columns, what are the recast columns. Here you can see that I'm specifying all of them to be doubles, which are floats. I'm also specifying which columns should be filled in and with which values. These are these dictionaries that we saw created right here. Here I'm setting them explicitly because that's how the production level pipeline is going to work. All of this stuff is going to be pre-specified. And then I'm specifying the pipeline itself. So you can see there is a few simple steps that we did. First of all, we write in the data using a delimiter. Then we set the timestamp, TS. We read the Unix time, and then we did it to a timestamp so that the DT column becomes a timestamp column. Then we transformed our columns to day, hour, minute, and second. Then we renamed some of the columns. We dropped the static columns. We replace minuses with nulls. Then we fill in the values. Then we recast the columns, and then we fill in the missing values. And as a final pre-processed data pipeline, this is how it looks like. So yeah, this is going to be our data set with which we will be working. We can write it out to a Parquet file. And as you can see here, it's going to again run all of these processes, and then it's going to output it into a folder called processed PQ. That's what I've specified. And you can see that it outputs it as partitioned Parquet, which is the default format. And then to read it in, it's very simple, like we did with CSV, but now we specify Parquet. So specifying the file name, and we can read it in, and it should be exactly the same. That's it for today. I hope you found it useful. We did a lot of basics. They're going to be nice for a foundation for what we're going to be doing next. You saw how to read in data, how to process it, how to do feature selection, how to do plotting, and all the other basic stuff that you need to do in your data science workflow. So I hope that you enjoyed it. Don't forget to like, subscribe, and I'll see you in the next one.